Bhagya. You don't know kinetic energy equation. How to derive it? Yeah? Yes, no? Kinetic energy. As the statement name it gets kinetic. So in motion. Right? We have two things, right? Kinematics and kinetics. One with cause of motion, other is without cause of motion. So kinetic energy. What kinetic energy? Let us take an object. Okay? This was a stationary. It was a stationary having a mass m. Okay? And it was velocity which is equal to 0. Okay? When it is hit with some force. When it is hit by some force, what happens? It hit back. Okay? So it moves further and stops somewhere else. Correct? And this is our final motion. On the path, even we don't know where it stops, it keeps moving. So it having velocity, okay, the moving velocity called v, so called final velocity. What is v called generally? Then having mass changes? No. And take a displacement rate from here to here. Displacement start at d. Okay, so we know this kinetic energy definition, okay, direction you do by two parameters. One is by work energy theorem, first one. Second one by Newton's second law. Newton's second law of motion. First we go work energy theorem. What work energy theorem? They are related with the work energy. What work? Work equal to work. Force into displacement. Perfect. Okay. And again dot product. Don't worry. Okay. So now here, as per Newton's second law, F equal to Merima and into displacement. Mad. Right? So you should be mad to learn. One. Which notebook? Some kind you check, right? Goldfish, silverfish. Silverfish. When I read silverfish, then I got. You just observe and keep for 1 or 2 months. Just open it. So
All went to
small, okay? As the insect comes out, it is silver in color. Don't judge when we are cleaning, right? In books. Right? A small silver comes. Silver color insect comes outside. You not observe, just observe while cleaning. Cleaning your books. Obviously, it's under the book. And pustakadu oda anta
okay. My 11th standard books went.
All 8 insects, 8 insects.
So pustakadu right? Silverfish. If silverfish there is no compulsion that should be in water only. Silverfish is a fish, is an insect which is available always inside the book. It eats the paper. That's called silverfish. Adike pustakadu oda antalla. Silverfish is a pustakadu oda insect in book. Unfortunately, fish in silverfish in book and regarding silverfish in the book only. Yeah? So, work done. We go to mad. But next. We know third law. So, you know, motion equation V square equal to U square plus 2AS. Okay? So further, we know S is displacement. Correct? So now, alright. V square equal to U square equal to 2A instead of S, alright? D. So, initial velocity obviously the body at rest. Okay? V square equal to 2AD. Call as. Okay, don't call, nothing. will go now. I want AD is equal to V square by 2. Call as equation number 2. Equation 2 in what? Substitute submit equation 2 in 1. What you get? बोल करने ना correct. Change the kinetic energy. Kinetic energy. What is kinetic equal to? Work done. Obviously, both are same unit. Should I take like this? So right here, kinetic energy is equal to mad. I have mad. What is add?
V square by 2.
V square by 2. That is why kinetic energy is equal to V square by 2. Hope clear? We cannot. What do you mean by gravitational potential energy?
Potential energy due to gravity.
Due to gravity. Let us take case first one. Case 1. When object is coming down, okay? When a body falling, okay? With increasing what? Correct? Yes or no? Well, falling down, the speed increases or not? And hits the ground. Good. For this case, we have to analyze. No, very good. A body falling from height, some particular height. Got my word? So we take motion equation. Same. U square equal to
U square plus 2.
U square plus 2A. Yes. Correct. Perfect. And when body falling some particular height, it was 0, right? Some height, particular height, I'll take 0. What is it? This is equal to 2A. Yes. Perfect. No doubt. And one thing, when falling, it becomes G. Barabar? No doubt. Okay. Then to this I divided by what are? Yeah. What happens if you divide? And one more thing, I'll change this S. I change it as falling down, right? No questions? Divide M. What happens? EMD square is equal to RHS, right hand side, 2GH into M by 2. Barabar? 2 1s are 2, 2 1s are 2. Of MV square equal to MGH. That means what do you got?
Kinetic energy is equal to potential energy.
Energy conserved. What happened? Energy is conserved. There is no loss of energy. Potential is converted to kinetic energy, or kinetic has to potential energy. Vice versa. What is?
Then multiply will come by division and divide.
To me?
Divided by.
And we mathematically I go one point. Mathematically we will discuss first. We will get an example everything. Y. Mathematically. How can I take mathematically? Tell me. Mathematically. So potential energy, if moving along x, I'll take it as mgx. Correct? Agree with this?
Yes.
Yeah. Now a small change potential I'll take in terms of dp of x towards the denominator becomes dx. So I'll take mg. Okay? And mg means Newton second law. Mary mass Perfect. Why x I'm taking both sides? Any idea?
Check is moving on the
Yes, yes, yes. And always when body moving downward, it has a negative, right? So I'll take why negative? Because of gravity is pulling, coming down, we take negative.
But object is moving like this.
G. Bolo G. Parle G. If you use this, I'll come to the one first. Don't come to this first question. You should clarify clear one more. That's different word. Finish up mathematically. So take next again. dv of x by d is equal to minus f of x, correct? Now cross multiply. What to do? Cross multiply. What I have here? Minus f of x dx, correct? What should take here? What do you get? Minus f of x dx is equal to what do you? Shall I write like this? Changing what? Possible? Possible or not? Still a doubt? From this equation, right? M job level, no issues at all. What I can write? dv. dv by dx what? dv by dx. That means what? Acceleration. Correct? Same thing you got above. Now comfort. What I done? I just change sign, that's it.
How we can
How?
we
Good question. Let's balance the unit. Let's balance the unit. What's the unit of force? Unit of force? Newton. Unit of distance? Again, Newton meter. Yeah, Newton on the what? kg meter per second square. Perfect. Velocity?
Meter per second.
Meter per
Second.
only that much. What about mass? Mass. Both sides balance, right? Meter per second. But what I have? F of x dx.
Force is to distance means velocity
Force into distance means?
to velocity that only happens.
This will not get it, right?
That one because force into displacement means work done also.
How do you get? Here on the answer below. I'll come to that. I run from both sides. This is actually not required, but I'm just even mathematics should clarify. Tell me. So up to this, no doubt here. Okay, any doubt here up to that?
No, sir.
Okay. So here you know that up to this dv by dt is equal to. Is it clear? Okay. You got doubt with the how I got velocity. F of x dx into v dv, right? That was a big question. Think. Anyway, you put some ink. Work out the basics.
Force into displacement is equal to work done, sir. Then why
Good.
they came, sir?
Velocity. Change in velocity. It is not velocity, it is change in velocity. What are you going to check here? F of x is equal f of x dx equal to dv. Correct?
Yes, sir.
F is equal to dv. Perfect?
Minus, sir.
Minus sign. Happy? So here, check somewhere something.
If we substitute, sir, f is equals to ma and x, then m into v by t into s we will get, no, sir. There we got v square by t, sir. M is.
Tell me, just to make it up. Only in WhatsApp you can find low. GIF. Notice it? So, what happens if you apply limits on integration? On integration, what happens? Can you guess? I'll take this one as okay. F of x is the what? It will be xi minus xi. X minus xi. I'll take only this one. What happens? Minus. If apply limit dv means the integration of dv become v. What becomes? It becomes v with the limits vi and vf. Further, what do you get? Minus as is upper first. Vf minus vi. What do you get? Vi minus vf. Correct? This is what I want. Ultimately, what we got? What PFS it is? PFS is what? Potential energy. Correct, is equal to Vi minus Vf. This is towards here. We will take here V. Correct now? That's it. Is it clear? I hope it's clear. So just why it takes your time. You'll practice this one. Minimum tomorrow homework. 3 times enough? Give me a question only you have an answer. Because then why not this young mind? G. Catching a file here. Potential energy depend upon initial velocity and final velocity, not reverse. Because that's final, what happened? It will come to rest. And I have a chalk here. It times initial velocity when I throw it. Initial is final. What happened? Final 0. Initial velocity. So the time Vi minus Vf. Done. Next we have conservation of energy. What is conservation of energy? We will discuss. This one done, ma?
Yes, sir.
Yeah, no. So we go conservation of energy. What conservation meaning? Conserve is what? What?
Reserve, sir. Reserve.
What?
Preserved.
Preserve. Okay. Next. Conservation. What non-conservation?
Which is not preserved.
Not preserve. Good. Generally preserve, right? Some antique pieces. Some special. If you have any, right, any given by some, if you receive from any, right, very well-known person, something, some gift, you preserve it. Some school of kottidane. Okay? Preserve it. It's conserved. When you know it is destroyed, not again, there is no modification done to it. We just preserve it. So again, we'll go conservation of energy. What conservation of energy? First law of thermodynamics. You see it? Energy never created, not be destroyed. But it can be transferred from one form to another form. This is called first law of thermodynamics statement. The same thing. Energy conserved, that means it won't be destroyed or not created. It transfers from one form to another form. And make sure while doing that, it depends upon initial and final states. It depends upon where? Initial and final point. And one thing, it does not depend upon path followed. ನೀವು ಹೆಂಗೆ ಬಂದ್ರೆ ಕೇಳಂಗಿಲ್ಲ ಎಲ್ಲಿದ್ದೀರಿ ಇಲ್ಲಿದ್ದೀರಿ where you are and now where you are. So depend upon only on initial and final point. Initial and final point. Non-conservation, non-veg. ಕೇಳಿರಿ what non-veg? Veg. Pure veg board I have. We saw symbols like this we use. If it was in product, no, don't confuse. If you take Parle-G, Parle-G symbol is nodiri. Green symbol is nodiri. Andre enadu? WhatsApp live aytanta. It means it is veg. Made up of plant-based raw materials. Suppose it was is a green. Suppose it was a red, lal. क्या होगा? Non-veg. Why red color they chosen? Why not give yellow color? A pink color, favorite color. Meat. All animals, cold-blooded animals, maximum meat because we are cold-blooded, right? So meat, okay. This is a red color is red. Even meat color also red. It's called pink revolution. You know, right? Who is the white revolution man? Man of white revolution. I asked somebody. Man of white revolution. Varghese Kurian. If you lost to see what it means. So, challenge after day, that's why I just added out of the box 9 general questions. So, red. Red is as well as pink revolution to right promote more and more available profit food. Then, if it was one more color, so called brown. Brown. We did not start this one, right? What is it? Brown dot. And that way brown dot. It was Snickers. Snickers something. Snicker. Okay, good. This brown nothing but it was egg based. Yeah, based on egg based. Okay. This question was asked in IAS. They ask common sense questions. ನಾವೆಲ್ಲ ಗೊತ್ತು ನಮ್ಗೆ ಗ್ರೀನ್ ಗೊತ್ತು ರೆಡ್ ಗೊತ್ತು ಬ್ರೌನ್ ಭಾಳ ಗೊತ್ತಿಲ್ಲ ರೈಟ್ ಸೊ ಸಿಮಿಲರ್ಲಿ ಕನ್ಸರ್ವೇಷನ್ ಎನರ್ಜಿ ಐ ಬಂತು ಸೊ ವೆಜ್ ನಾನು ಡಿಲಿ ಬಂತು ಓಕೆ ಸೊ ನೌ ಹಿಯರ್ ಇಟ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ಓಕೆ ನಾಟ್ ಡಿಪೆಂಡ್ ಆನ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ಇನಿಷಿಯಲ್ ಅಂಡ್ ಫೈನಲ್ what point and make sure it was again independent of path. This will depend upon some house ಹೆಂಗೆ ಹೇಳ್ತೀರಿ on what basis ಹೇಳ್ತೀರಿ ನೀವು tell depend upon path because while moving path it loses energy. Okay, on the path it loses its energy. This is called it depend on path. Depend upon path. Examples. So give me some examples. What samples? When you go to sweet shop to purchase for birthday or anything what function, ana peda padadilla. So sample padadu first. Correct? We take sample and thinking. Okay, vadantane ellu munna nodtanu. Adra yav vishasta then we bring it. Same thing. You got some sample. So what sample for non-conservation of energy? What are sample for energy? First one, I can take the most important famous.
Friction.
Which one? Frictional force. What's the force? Can you conserve friction? Huh? Conserve friction? No. What about viscous force? So viscous ball ಹೇಳ್ತಾರೆ ಅದು ಬೇಸ್ ಬೆಟ್ಟ ಅಂತ ಹೇಳ್ತಾರೆ ಇನ್ನೇನು ಬೆಟ್ಟಗೆ ಇವರು ಬರ್ತಾರೆ ಆನ್ ದಿ ವೇ ದಿಸ್ ಇಂಟ್ರಡಕ್ಷನ್ ಐ ವಿಲ್ ಕಾಲ್ ಇಟ್ ಟೀಸರ್ ಕೂಡ ಅಷ್ಟೇ viscous force these two are okay called generally called non conservation we can't conserve those friction force as well as viscous force and what about here conservation of forces gravitational force we can conserve correct gravitational force object is there it has potential energy that means due to gravity that potential is converted into kinetic energy and when falls on the ground what
Rest.
not at rest it was again converted either in the form of heat or in the form of light okay other form of energy transfers this is loss of energy so example yeah gravitational force one more one second la unna bekla chapati ಒಂದು second ಅಲ್ಲಿ ಚಪಾತಿ ಬೇಕಲ್ಲ ಊಟ ಕೂತ ಒಂದೇ ರೋಲ್ ಚಪಾತಿ ಬೇಕು ಸೊ ತುಪ್ಪ ಹಚ್ಚಿ ಸೊ ಬೆಲ್ಲ ಹಚ್ಚಿ ಸೊ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ ಸ್ಪ್ರಿಂಗ್ ನೋಡಿರಿ ಟಕ್ 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 ಮಾಡ್ತೀವಿ ಸೊ ಪೆನ್ ಇಟ್ ಬೌನ್ಸ್ ಮಾಡುತ್ತಾ ಹಿಂಗಿಟ್ಟು ಬೌನ್ಸ್ ಮಾಡ್ತೀವಿ ಟೇಬಲ್ ನೋಡಿರಿ ಹಿಂಗಿಟ್ಟು ಟಕ್ 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 ಜಿಂಗಿರ್ತೀವಿ ವೈ ಬೌನ್ಸಸ್ conservation what is stored same what come back it's called bouncing no doubt conservation of forces conservation and non conservation of forces energy I thought of today finishing spring force up to that spring energy. You work to the flow of the out of the box, these things you should write. Silverfish written. Edit some short forms you make. Okay, don't write short form. Write elaboration. You know, we have one course, short handwriting course. You heard? Short handwriting course. Clear? So it was even government call for them. Delivata. You know, lawyers, wakils, they are assistant, right? They are keep on telling their articles, names, and so on, so regarding case. So they are assistant, right? They write this short handwriting. What did I write? This entire thing you can write in one line.
Stenographers.
It's not stenography. Stenography is different. Short handwriting is different. Calligraphy, you heard? Calligraphy?
Yes, sir.
Calligraphy is one of the course, but it's nowadays no one interested about calligraphy.
In our class, someone took course.
Oh, super. For instance, views only.
No, sir, in 10th, sir. We were in 10th. He learned for 3 years, sir. From
Calligraphy.
8 to 8 to 10.
No, that's nice calligraphy. Nowadays we have got even app and software, doesn't matter. But calligraphy, you know, our Indian constitution, written constitution, longest written constitution is ours. This will be preserved in a helium gas. Preserved in a museum. Which is handwritten by two very famous calligraphers. I can't recall the name. They written entire all articles, all schedules, and everything written. Done. So conservation of mechanical energy. We go for it. What mechanical? Conservation of mechanical energy. What conservation of mechanical energy? So, when the mechanical energy conserved, then I can say, total energy also conserved. Correct? If these both are conserved, then what I can say? Barabar? Okay? So let's take an object again, same story, and subject is moved by a force, under force. So we know change in kinetic energy is equal to Kf minus Ki, and this was equal to what? Change in kinetic energy. Change in kinetic energy I can take with what happens? It moves from distance from xi to xf. What can I do? F of x into dx. Correct? Along with integration will apply. But just to recall previous page, we have a very beautiful term for this. What was that?
D.
Yeah.
D.
Potential is equal to?
D.
Yeah. No, further. Equal to xi, xf, f of x dx is equal to vi minus vf. Is available? So let us substitute in our equation. We substitute what happens? Final energy minus initial kinetic energy. Final energy is equal to what? Vi minus Vf. And what we in general take? We take potential energy. Initial potential energy and final potential energy. We generally denote as V. Don't confuse. Potential energy you can denote as Vi also. V. Okay? If you don't confuse. We denote as V. You can take P also. Why not take P? Because last time we taken P as a momentum. P or J? What are taken? I don't know. J I think. Momentum. What time? Check now. Potential you can note taken as notation of V. Momentum is taken. That's why I just want to change. Yeah. So now on the rearranging Ki plus Vi equal to Ki plus theta. That means what? That means initial mechanical energy is equal to final mechanical energy. Hence, total energy is conserved. Got it? Hence, you should write total energy is conserved.